One.
Hi everyone, and welcome to the Arquillian booth talk. My name is Knutsen. I'm from Red Hat, and
And my name is Majsak, and I'm a committer to Arquillian project.
so how many are familiar with Arquillian or know what it is? Everyone, awesome. So the this talk is trying to focus on some of the more unknown aspects of Arquillian, the things that you might not have seen before or weird testing solutions. So we're not going to go into what Arquillian so much is and how it works, except that it's a testing platform for containers that handles the life cycles of deployments and the likes. But it also has the ability to bind in different testing-related services. So it's the first step. We're going to look at a project that's called Arquillian Drone, which is a wrapper around the Selenium and WebDriver APIs, and how you can integrate and control the browser and the deployments. So looking through you're kind of in the middle of the screen here. So looking at from the beginning, we have this standardized Arquillian stuff. You run with Arquillian, hands over the execution to Arquillian, and then you define your environment, what you want to test, the deployment. And then through the Arquillian drone integration, you have the option to inject a finished initialized WebDriver object. And at that point, you have control over the WebDriver and all of the different drivers that the Selenium API support. So it could be Chrome or Firefox or Android or whichever. Even more? Oh, there you go, okay. So this test is using what we call the page objects. So it's trying to encapsulate the interactions in the browser into a Java API, so it's easier to understand and easier to program and not spread all the expressions around the whole test class. You gonna say something about that?
Yeah, so basically if you stick to the low-level Selenium API, it's very hard to maintain those tests afterwards because you are operating on the HTML DOM concepts. And if you encapsulate it in the so-called page object pattern, then you can actually structure or provide a DSL which will describe not what the browser should do or where the mouse should click, but what actually user should do as exercising your web application. So then you basically have a DSL which kind of express how the application should behave. So therefore, you not only gain tests which are easier to maintain, but they are definitely way easier to understand, and they actually express precisely what the feature is supposed to do in the application. So we came up with some simple web app here. We call it the Beer Advisor, and we have bunch of tests. I guess I need to jump here. We have a bunch of tests just highlighting features we implemented. So there's one feature where we basically search for the cheapest beer, and yeah, basically as you can see, it's quite simplistic. But what I do here is I search for the cheapest. So I have some sort of let's say, natural query language built into the application. So yeah, I think we can just start it up. Okay. Does it work? All right, so you will see now Chrome, which we are using as a browser of choice for the tests. And we basically run several examples here. What happened is we have a black box test, so we don't really have any kind of knowledge of the internals of the application. We exercise it as an end user. So in this case, you see we use Arquillian as a deployment engine. There is no magic on the server side, no extensions whatsoever. We just say, hey, Arquillian deployed our web application, and then we do all the interactions through WebDriver API or through page objects. And yeah, we kind of try to structure those tests in a BDD approach. So you can see these comments given when then, which is some sort of I guess, Gherkin language. So what it effectively means is we divide our test in, let's say, 3 areas. First, in the given section, we actually specify the initial conditions or test fixtures. Then in the when block, we exercise our component under test, or our, in this case, our web application. And the then block basically is used either to assert the state or the behavior of the component. It's kind of nice, but it's JUnit, and JUnit is a bit low level. It's not really designed to be as expressive as we would like to have for BDD tests. So we actually have integration not only with JUnit for Arquillian. We actually have we have also TestNG, and we actually have Spock. And Spock is Groovy-based testing framework. It's more BDD oriented. It's not really full-blown BDD. It sits somewhere in between. But as you can see, the tests are formulated in more like a narrative way. It's easier to basically describe your test as a feature and interaction rather than what you would do in JUnit. So here we actually have pretty much the same things in the test. So I guess we can skip to the and jump to the other black box testing we have. So the next part would be testing the REST APIs, right?
So similarly to drone, it's basically the same setup to be able to test REST, right? You need something to call on the server side. So we have our deployment. We're running the test case on the client side of it, and then we're using Rest Assured, which is another kind of groovy-ish, fluent API to set up the different requests. So in this case, we have no control over what's going on the server side, except that we're sitting on the outside and poking at it. So we're similar to the Spock in the BDD style. We have a given, when, and then situation. So given that we have a specific parameter to our REST service and we're trying to get that resource, we can verify that the status codes and so on are the same. So this is Arquillian with third-party library. So Arquillian is doing the deployment and the injections of the URLs to the targets, while it's Rest Assured that actually does the assertions and the testing. And the interesting thing, of course, with Arquillian is that it integrates with the IDE and just relies on the normal JUnit integration. So all you need to do is right-click and say run. Now, we have a JBoss AS server that is already up and running, and you'll see the deployment happening, and well, yeah, it's done already. You mean the Jersey test, or? I'm not sure actually, but probably. I would have to try it. But if it just does the REST testing, then sure, yeah. So that's still a black box testing. Warp or Byteman, right? So let's see. There is a project at JBoss that called Byteman, which allows you to runtime manipulate anything that's in the JVM. And there is an Arquillian integration for it as well. So if we look at, in this case, we're still trying to do the black box testing, but we're annotating it with a Byteman rule that says that when you're hitting the bare resource, which is our REST endpoint, on the method get bare by code, which is our get response, throw an exception instead of doing what you're actually supposed to be doing. So we can look at the bare resource. Well, so this is the actual code, right? We're not changing that at all. We're just deploying that class as it is, but runtime, we're overriding the get bare by code to throw an exception instead. And you could do a lot, I mean, you can rewrite the different positions in the methods. You can use it for tracking different threads and that kind of thing. So as we saw with the So when we run that, we get a fault on the server side instead. But the test still passed because we're actually checking that we get an internal server error as opposed to something else. And that's the same REST service that we actually tested before. Oh, gray box, right. So that was black box and kind of gray box-ish. So, you want to take it?
So we obviously know about two flavors of testing. We covered black box testing, so we don't have any knowledge of what's going on internally in the system. We obviously have like unit tests or integration tests where we know what's going on, so this is a white box testing. But there is also something in between, which is called gray box testing. So what we can actually do, and what we are doing in this example, is we still exercise our REST API, so we call it from the outside, but then we have a warp extension in Arquillian, which can hook in to the server side and basically verify some interactions in the server. So we can exercise it from outside, but also peek into the internals and see what's going on. In this case, it's actually very simple, and maybe not the state of the art, but for the sake of simplicity, what we did is we basically send a delete request, and then once this one is completed, we call the JPA repository underneath, and we verify that actually the entry is not in the DB anymore. So yeah, we can try to run it. And again, what's going on is Arquillian will deploy the whole test. We will run it from the client, and then at the end, Warp will invoke the JPA repository to verify that, that the entry is not stored in the database anymore. Okay, so now we're going to have a quick look at the integration tests, in particular into the persistent extension. So first, maybe we can actually see how we would do it in the naive or lazy way. So what you would do for testing your JPA repository, for example, you'd for sure need to have a transaction, because if you call the JPA or EGB service, then it needs to be wrapped in the transaction. Then before the test, you probably will need to clear the DB just to start from the known state. Then you insert some data, you obviously start the transaction, and at the end you need to commit or roll back. And if when Aslak is scrolling down, you see that there is a lot of noise. You don't really know what's going on in this test unless you hit line 142, where there is this simple test which just verifies that we have some criteria query which is finding the strongest beer. And we can actually do better than that. If you know DB unit, we have integration with it. So instead of writing all this boilerplate, which is actually not that nice because you will need to maintain it, and it's not really flexible if you would like to have different data sets for different scenarios, we actually have concept of data sets which you describe in several different formats. We have YAML, we have JSON, we have XML, which comes out of the box from DB unit, and also Excel if somebody likes to define data sets in Excel. We can actually have a look at the file. It's a DB unit, so it's oriented. It's a database schema oriented, so we actually define each and every row in the DB. But as you can see, it's entirely externalized, so you can actually have a lot of different configurations for your data and run the tests without really taking care of setting up all these objects by hand. So let's try to run this test, and then we can actually elaborate a bit more what's going on. So now Arquillian will deploy the whole test suite. And each and every step, we start with clearing the database. We take the external data set, we apply all the entries, and then we are ready to go and interact with our JPA. And we have also another feature. I think it's the last test here. Yeah. So instead of, let's say you have a large data set and you know how it should look like after performing some heavy computations, there is little to no sense in actually verifying through Java code. So what you can actually do is you can provide another data set, and by using should-match dataset annotation, when the test finished, you will be able to use these row entries you define in YAML, and this will be compared straight and directly into on the database level. So yeah, it's pretty convenient. And by convention, we also wrap the test in the transaction, so you don't really need to take care of it at all. And then basically no boilerplate, no noise, just exactly what you want to test, and that's pretty much it. Yeah. Do we have something else to show? Yeah, that's pretty much all.
Well, if you, so there's another aspect to using the persistence extension is that you also have it interacts with the Arquillian transaction extension. So you could, on any test method, basically say transactional and transaction mode. Come on. So you can have it either start a new transaction around the test method, or you can have it roll back, or potentially disable the whole transaction. So you want to do it manually instead. It gives you convenience of similar to how the EGBs work, basically. And as far as demos we had, that was about it. Does anyone want to questions or want to see something specific? Yeah. So the question was, is there any way to be able to package up libraries that are in Maven, or to read your Palm configuration to add more of the different external libraries that you have? And Shrinkwrap has something called Shrinkwrap Resolver. Do you know where we use it here? Do you know where we use Resolver?
Yeah, in the deployment for drone, for example.
For drone, okay.
Yeah, just try look for a deployments class.
Oops. Yeah, there we go. So this is the API for Maven Resolver. You're basically giving him the artifact IDs or potentially the versions, and you can pull in the transitive dependencies and add it to your deployment. And similar, except that you use Gradle.resolve instead. You can use the same for the Gradle build system. Yeah. Anyone else? Questions? No? Okay. Well, I think that's all. Thanks, guys.
We're actually now going to give away